When iron goes through fire to become steel, its properties are determined by treatment processes and additives. For example, adding chromium, molybdenum and nickel will improve its resistance to oxidation and corrosion. The result is what we call stainless steel. With its durability and bright surface, it has proven itself in everyday use and in works of art, both outside and inside, on buildings and underground. Careful treatment during and after processing is one of the factors ensuring that stainless steel retains its finish even when it has been made into products. Engineering chemicals from Oakite Europe are an important part of those treatments. Stainless steel is shielded from corrosion by the so-called active protection, which is an extremely thin layer of chromium oxide only a few atoms thick, about 2,000 times thinner than a human hair. Mechanical operations such as drilling, turning, or milling destroy this layer. Normally it regenerates immediately, provided the surface remains completely free of contaminating substances. These include splashes of foreign metals or deposits of carbon steel produced when white and black materials are processed on the same machine, or contamination caused by footprints, perspiration and dust. The resulting damage to the passive layer leads to progressive corrosion, which can very quickly destroy the usefulness of valuable equipment and facilities. Welding also removes the passive layer. The oxides produced during welding cause potential differences which promote the electrochemical process of corrosion. Complete removal of these oxides after welding is the only way to prevent this. Stainless steel is usually welded with the tungsten inert gas or TIG process. Even the very thin oxide films generated by this method can lead to corrosion. They must therefore be carefully and completely removed. But how? One simple method is grinding, but that is highly problematical and unsatisfactory in terms of corrosion. High removal rates cause surface stresses, leading in turn to stress crack corrosion. Any substance containing chlorine will then cause blistering. The cross-section shows how deeply corrosion has penetrated after only a short period of time. Laboratory tests confirm that in a 10% iron chloride solution, the untreated weld will resist corrosion longer than a ground weld. This real-world example shows pitting corrosion on the ground surface of a wine tank. After only a year, it has perforated the tank, allowing wine to leak out. So let us consider a different surface treatment. Blast cleaning, using iron-free media, of course. Glass bead blasting, for example, not only cleans the surface, but also converts any existing tensile stress into compressive stress. That reduces the risk of stress crack corrosion. On the other hand, however, detached oxide particles or glass fragments can damage the metal surface. The resulting potential differences lead to typical corrosion phenomena after only 2 weeks of exposure to an aggressive atmosphere. For comparison, here is a ground surface after the same treatment. The alternative? Stainless steel pickling products from Oakite, under the Antox brand in Germany and the Cheminox brand in other countries, certified under ISO 9001, based on intensive monitoring from incoming raw materials through to the finished product, and sophisticated analytical methods, from atomic absorption to computer-aided documentation. Pickling products for specialized surface treatment of stainless steels, including colorless Metinox 71E stainless steel pickling paste for removing scale and tarnish from welds. Metinox 73E stainless steel spray pickle for welds and surfaces. Or Metinox 80E, a pickling concentrate for preparing immersion baths used at ambient temperatures. There are a number of different pickling methods. One involves applying a pickling paste such as Metinox 71E with a brush. This cleans the weld and the adjacent heat-affected zone. Pickling time depends on the alloy, the temperature and the effectiveness of the pickling paste, but is generally about 1 hour. Metinox NP neutralizes hydrofluoric acid in highly acidic stainless steel pickling pastes and binds heavy metals. Bubbling indicates the reaction between pickling residues and Metinox NP. Finally, the treated parts are rinsed thoroughly with high-pressure water, removing all traces of scale and tarnish. The immersion method using Metinox 80E produces completely clean surfaces, thoroughly cleaning not just welds, but also the surrounding metal surfaces and hence providing better corrosion protection. The exact pickling time must be determined by preliminary testing. That time must be strictly observed in order to achieve the desired result. If necessary, Metinox 80E can also be used for more aggressive immersion, for example, to remove stressed surface layers. The amount of material removed depends on immersion time in the bath. Immersion pickling is again followed by high-pressure rinsing. If the shape or size of the parts precludes immersion, the pickling agent Metinox 73E is sprayed on. Once again, of course, the surface must be clean and grease-free. Since oil and grease are not attacked by acids, they must be removed before pickling with an oil-dissolving cleaner, such as Metinox 75E, which is either sprayed on or wiped on by hand as shown here. Metinox 73E stainless steel spray pickle pickles both welds and surfaces in a single operation. It is sprayed onto the surface using a diaphragm pump driven by compressed air. Metinox 73E is a thixotropic pickling gel. Mechanical stress changes its viscosity. As a result, it adheres even to vertical surfaces and acts quickly and reliably. Scale and tarnish, dirt and foreign metals are all dissolved. Normally, the base metal is removed to a depth of less than 1 micrometer, but removal rates of about 5 micrometers can also be achieved if necessary. Once pickling is complete, residues must be rinsed off. The best rinsing method is cold water at high pressure, at least 1,800 pounds per square inch, sprayed onto the parts from top to bottom. Metals dissolved in the rinse water, such as iron, chromium and nickel, as well as dust and other contaminants, must not be allowed to enter sewer systems. Local wastewater regulations must be observed. With additional processing, treated rinse water can be reused. That is both economical and environmentally conscious. The only waste is a hard filter cake that must be disposed of. Any tarnish or scale present before treatment is removed in a single step. The result is a clean surface with reactivated passive layer. In the ASTM salt spray test, ground and abrasive blasted samples exhibited corrosion effects after only 24 hours. Pickled specimens, however, remain corrosion-free for at least 720 hours. That's 30 days. Our goal is to preserve and protect the enduring beauty of stainless steel and the products made from it. to extend the useful life of valuable capital equipment and preserve the lasting beauty of its appearance.